Hey everyone, this is Sid from Comet. As you may have heard by now, Comet recently open sourced a cool project called DataGrids. DataGrids is a tool which empowers data scientists and machine learning engineers to view and debug their image data. Today, I thought I'd walk you through how I use DataGrids to visualize my data for a reinforcement learning project. Here, I'm using a library called PyBullet to render my simulated robotics environment. The goal of this RL task is for the robot to move to a position directly above the object on the table so it can grasp it. The state or observation of this environment is the image of the scene from a simulated camera. The action that my agent will take is the relative XY movement of the robot's end effector, and the reward function is the negative distance between the robot gripper and the object. I'm going to train this environment for a while, and while it's training, I'm going to want to save the agent's experience in the form of a replay buffer. For each step, a replay buffer logs the original state my agent was in, the action my agent took, the new state the agent is in, and what was the reward of this action. Replay buffers are useful for two reasons. One, I can use the replay buffer as an input to my offline or batch RL algorithm to continue the learning process without needing to run the simulation. Two, I can use the replay buffer to further investigate how my agent is training and see specifically where it is failing or succeeding. Since in my case, the state is an image, DataGrids makes a great data structure to store my replay buffer in. Here's how I use DataGrids in my current workflow. I created a DataGrid gem wrapper to help in auto-logging my replay buffer. If you are familiar with pandas, the syntax of DataGrid is very intuitive. Here, I simply instantiate my data grid with a column names of state, next state, action X, action Y, reward, terminated, truncated, and episode number. Then, for every time my step function is called, I simply log my experience as a new row entry to my data grid. Now, I'll pass my custom environment to the data grid wrapper I created, which I then in turn use as an input to my RL algorithm of choice. And then finally, I save the data grid to a local file. Now that my training is complete, I'm going to now open the data grid with a simple command. This is what my data grid looks like in the UI. Notice how I can see images, scalar values, and booleans all in the same row. Here are a couple ways I can use a data grid to develop a deep understanding of my data. First, I can click on an image that I stored in my data grid to further inspect what's going on and even interact with it. Second, I can group my data grid by columns. Here, I've decided to group my data grid by the episode number. If I now click on the state variable, I'm actually able to see end-to-end how an entire episode played out. 3. I can also filter my rows by column values. See how I can use this feature to define a reward boundary so that I can only see entries where the robot was close to the object. Whether you're working on a reinforcement learning use case or a supervised learning use case, DataGrids is going to make it very easy to visualize and interact with your image data. Feel free to check out our GitHub repo to start using and contributing to DataGrids today.